Have we started?
Mm-hmm.
All right, everybody. Experiment 27 is the acetylation of ferrocene, and we're scaling it up. So this is real scale chemistry, unlike the micro scale chemistry you've been doing all semester. Okay. So what does it say we're going to start doing on the sheet? Right there.
To a something ml beaker.
To a beaker, and we have lots of beakers. And what does it say we're going to add to this beaker?
Something ml of anhydrous methylene chloride.
How much methylene chloride?
0.72. No, methylene chloride.
Is it for the ferrocene? I believe it is. Yes.
Right.
So how much methylene chloride?
9 ml.
9 ml. So we're going to do 9 mLs. Pretty close. And a little closer to 8, but it's solvent. So are we that concerned with solvent? Not usually. So we have 9 mLs of dichloromethane. And how much ferrocene is going to go in there? 0.9 grams. 0.9 grams of ferrocene. And the ferrocene we have pre-measured here. And notice it is a rust-colored substance. We should not be surprised by that. And we're going to put it in our 9 mLs of dichloromethane solvent. And try to get all of it. And what are we going to put it in? Oh, we're in the hood. I think we're going to put it into a special device. This device here. Notice this device has a spigot and it has a side arm. Otherwise it looks pretty much like this device, a separatory funnel. They both have a spigot and they both can be stoppered. This is not good for pouring though if it's got the stopper on, because after you pour, a vacuum happens here and it stops pouring. This device over here has some clever engineering. I can leave this stopper on and pour the liquid out, and a vacuum does not happen up here because air goes back this way and equilibrates the pressure. This is called a pressure equalized dropping funnel. And this here is a 30 milliliter pressure equalized dropping funnel. And I need a stir rod to homogenize my solution. I notice I spilled a little. We're homogenizing our ferrocene solution. Burgundy color. Get the lid off here. When we're pouring in here, we got to make sure we don't pour over the air equilibration arm. And there's our ferrocene, which we'll add slowly to our reaction mixture when we need to. Right there. Now we need to make our catalyst solution as well. And how much aluminum chloride are we going to put in there?
1.35 grams.
1.35 grams. I'm going to rest this over here for now. 1.35 grams aluminum chloride. Aluminum chloride's our catalyst today. Here's the reagent. And how much you said? 1.35. You got it. Now how much dichloromethane this time? 15 ml. And go a little over to compensate for going a little under last time. And this solution is not a solution. It's a heterogeneous mixture with some cream-colored aluminum chloride that does not dissolve. And while we get this set up here, and I want to seal it because moisture is our enemy today. We're going to make sure it's in here and it stays dry. So we have a pretty interesting setup. We have a 50 ml round bottom flask with a magnetic spinner. And it's spinning. We have a Claisen head equipped with a drying tube that has calcium sulfate in it. There's a septum here with this needle connected to our drying tube. So now our system, it's still open here, but it's definitely dry. There's drying agent in here. And we're ready to add this when we need to. All right, now where are we on our instructions?
Acylation head equipped with the tank.
Yes? He's just reading basically what we've done.
We need to add acetyl chloride.
Acetyl chloride, very dangerous chemical. We're dealing with two very dangerous chemicals today. In fact, I want to prove just how dangerous the aluminum chloride is before we add the acetyl chloride. Aluminum chloride was that powder I put in the flask recently. We have aluminum chloride for a demo here. And I'm going to put that at the back of the hood. And you carefully try to watch the flask. I'm going to put water in it. And I got it in the hood for a reason. You will see why very soon. Oh my goodness, what is that? There's white smoke coming off of there. That's hydrochloric acid. You don't want to be breathing that. So very dangerous catalyst. All right. We also have acetyl chloride, another dangerous chemical. We kept it in a desiccator. We're going to use a new syringe. And how much acetyl chloride are we using?
0.72 grams per milliliter.
0.72 milliliters. Fill it up fast. And down to 0.72. There we go. Putting the lid on. And we're going to add that to our aluminum chloride catalyst. It smells a little like vinegar here because the acetyl chloride will react with moisture in the air to create acetic acid, which is vinegar's active ingredient. Okay, good stuff going on. So we have our aluminum chloride in there with acetyl chloride. It's generating today's electrophile called the acylation ion. And what do we do now?
We need to add the methylene chloride ferrocene mixture.
Add the methylene chloride ferrocene mixture. I'm getting ahead. I'm ready for something. It says to add it quickly, slowly.
Slowly.
Slowly. That's a nice thing about our pressure equalized dropping funnel. And watch the color change after we start adding the reagent. You're going to like it, I'm pretty sure. There it comes. Oh yes. Nice purple. And we're going dropwise. Now we should be careful. This is a very exothermic reaction. If it starts generating too much heat and this starts boiling, we could be in trouble. So if it does get hot, I could put a cool water bath to trap the heat. But I'm not sensing it's getting warm. Nice spinning, adding slowly. And it says we're going to take a sample.
TLC aliquot.
Ah, we're going to take what's called an aliquot sample. Does it say after we've added it slowly to do that?
Yes.
Okay, so after this addition is complete, we're going to take what's called an aliquot. It's a very strange word that means a very small sample. And it's going to be for TLC. And pay careful attention to today's TLC because it's exactly the same as the final exam TLC. We'll do that on a separate video. So I think we're going a little slow here. This is not out of hand. We can speed up the proceedings a little bit. Oh, I'm getting bold here. That's a gush. Flask's getting kind of full. Maybe I should have chosen a larger flask. Ideally, you should choose a flask that only gets half full for a reaction. And I see some bubbling going on. It's not that warm, but it's definitely boiling. So an aliquot sample can be obtained this way. I'm going to store it in here. This has been used previously for this experiment, yeah, so it's got the same color. I'm just going to add to it. And an aliquot can be done simply by dipping a pipette in there, a small sample in there, and then rinsing that into our flask without knocking it over. There we go. We've made a TLC sample. So this would be representative of the early reaction mixture. We're going to let it run 15 minutes. So we're going to go to 8:30. So we can now stop the video.